Okay, Fusion 360, Lesson 2. Lesson 1 covered how to make lines and shapes and so forth in sketches, but those aren't going to be very useful in their unconstrained form. So, Lesson 2 is about how to structure your lines and shapes and so forth so that they maintain the intent of your design. I'm going to go over the available constraints very quickly, and then I will demo each one individually. So, horizontal and vertical, that is whether something is up and down or across. Basically, is it parallel to your x-axis or your z-axis? It will automatically snap to whatever it's closest to. Coincident is when a point or a line are in the same location. So if two points are coincident, that means they're locked together. If a point on a line is coincident, that means the point is going to be on that line somewhere. Tangent's pretty familiar for those of you who were in a geometry class recently. That is when a line is connected to a circle on just one point, not through the circle, not off of the circle, but on the circle. This is useful for making smooth transitions from a straight line to an arc, and it's also useful for just making sure that the edges are touching. Equal, if you have two elements that are constrained as equal, if you make a change to one, it'll change the other one. Parallel lines are two lines that are the same distance apart along their entire length. Perpendicular is sort of the reverse of parallel. That's when two lines meet at a 90-degree angle. Fix and unfix, if you have an element of your sketch that you don't want to be moving around while you're adjusting other things, you can lock it. This is also very important to know for when you are unable to move something, you may have inadvertently locked one of your elements or fixed, I should say. And that's look for the little lock, and then you can make some changes. Midpoint. So what midpoint does is fix what you select to the center of the line or element that you are choosing. And similar to the symmetry function, but slightly different, and we'll have you working with that so you see that. Concentric, it's when circles are parallel, that means they're concentric, when they share a center point. Collinear. Collinear is when you have elements that are on the same line. So there are line segments that you make. Sometimes we just call those lines. But if you were to expand that length off into infinity, if two things are collinear, that means they fall on that line. Symmetry. What symmetry does is it puts, this is one of the few things that you actually select 3 points for. If you've got two items and you want them to be symmetrical, you'll select one item, you'll select the midpoint, or you'll select the second item, and then it'll ask for the middle, what you want them to be reflected around. And curvature is a way to make a smooth curve from one element to the next. So, once we get into Fusion, and we have a new design, we can create a sketch, select, I'm going to go to the front, and we'll select the ZX axis. And I'm going to just make a simple rhombus here. And then I'm going to make a 2-point rectangle. Note that the 2-point rectangle has these little eyebrows. This is horizontal and vertical. It's already built in to when you say that you want to build a rectangle. But you can add them later under constraints here. We're in sketch mode, mind you. So in the constraints, here's the list of your constraints here. The first one is horizontal and vertical. So vertical lines are up and down. So I'm going to make both of those. And horizontal lines, you can think of the horizon. And now this is constrained as it would be with a rectangle. If I go back to the line tool, if I create a line, and I make just a single line, we can make that vertical. And if we had more complex shapes, L for line, we can notice that this one, because it's snapped to vertical as I was making that, it automatically referenced that as a vertical. But if I wanted to clean up the rest of this, I could certainly add a few of these to keep things square. If I click on this one, it's going to give me an error. And the reason why is because we've already, this one's defined as vertical, and we have another constraint here that says this will always be a 90-degree angle. So we don't need to tell it that this is also horizontal. In fact, if we said that this was, if we did that, then we would be what's referred to as over-constraining the model. So this is an error that you're probably going to see relatively often. So just keep that in mind. In the same way, this right here is the parallel. If I try to add a horizontal vertical constraint to this line here, it will also give me that error because this line has already been determined to be horizontal and this line is parallel to it. So it's already being forced to be horizontal. So you can't add too many, it won't let you add too many constraints. Okay, so we are going to look at the next constraint, which is coincident. You could think of this as L for line. You could think of this as connecting two endpoints together. Or you could think of it as putting an endpoint upon a line. So it's asking for the first point. So if I say I want this point and this point, oops, I'm still on the line tool. My apologies. I'm going to go to constraints, select coincident. So select sketch objects. So I'm going to select this point, and I'm going to select this point. And now, if we finish the sketch, if I move this around, you'll see that those stick together. It will even change the dimensions of this line to make that happen. If I move this point here, it will also move. Notice, if I go back, I'm going to right-click on sketches here. Oops. No, I'm going to open my sketches. Sketch 1. Right-click that. Edit sketch so I can get back to this. Notice that these also have the horizontal and vertical constraints. If I remove this constraint with a right-click, I'm going to hit delete. Now if I finish the sketch, we still have the coincident, and this one's still set to vertical, but now I can change the angle of it. It hasn't changed the constraint. If I try and click and drag the line, it will still do that. It's not changing the angle of this because that has been constrained. Okay, and this is also true for the rectangles, whether they were created as a 2-point rectangle or whether you constrained them afterwards. So that is coincident on points. If we go back to sketch 1 and edit sketch, we can make this point coincident to this line. So I'll select that, and then I'll select the line, see how it highlights. And now this line comes out until it touches this. So if I finish sketch, you can see how that behaves, where it will always, regardless of what I do, be on that line. Now notice that it is paying attention to the line. It is paying attention to the line regardless of where the line segment ends. And that's pretty important distinction to make. You know, it is looking at that imaginary line that goes to infinity. So that is coincident. It's going to make those stick, and it's going to change the dimensions and or the geometry in order to make sure that that endpoint is on that line. Next on the list, if we go back to edit sketch, on constraints, is tangent. So tangent is in relationship to circles, so we'll make a circle and we'll be able to see what that looks like here. So if I make this circle tangent to this line, it didn't move the circle. Okay. Now, when I move this circle around, it will always, again, it's following the line to infinity, but it'll always be to one, it'll always touch at one point. It's not going to cross through, it's not going to make a chord, it's not going to make a diameter, it's always going to be at that point. And you'll also see this if you make, I hit line for the line tool. You saw this when you made curves. See that tangent right here? If you were to continue this circle all the way around, this line would be touching it only at one point. That's how you make a smooth transition from one to the next. So that's tangent. And that can be very useful for making smooth transitions from a straight line to a curved line. And also useful for pinning circles in specific locations. Okay, I'm going to create a new sketch so that we can work on a neater platform. I'm going to make that one not visible. We're going to select the XZ axis as I have been. And now we are going to look at the next constraint, equal. So if we did a rectangle, it's been constrained to be horizontal and vertical. If we wanted a square, we could quite simply make this side equal this side and no matter how we scale this, it will now always be, the sides will always be equal. If we go back to Edit Sketch, if we make more lines, I'm going to hit L for line, and I'm going to make just a line segment here, and a line segment here. They don't have to be in connection at all. We could set them to be equal. And I'll set this one to be equal to this one. And now you can see that the equal sign is on there. And if I change the length of one, I change the length of the other. All right? That is equal. So back to right-click, Edit Sketch. We are going to look at the next one, which is perpendicular. Parallel, excuse me. So these two lines are equal. We can also make them parallel to each other. And as we talked about earlier, that just means that these two lines have the same distance apart regardless on where they are, like train tracks are parallel. Now if I go back into, so now if I change the angle, and this is an example of when I want to fix something. So I'm going to go to Sketch, Edit Sketch. We're going to constrain that with a fix. I'm going to fix that point there. There we go. Gives us a little green line there. We're going to finish that sketch. And now it should pivot because it doesn't want this to move anymore. And so now the lines are equal in length and always being parallel. I should be able to move that separately because the distance apart hasn't been constrained yet. All right. All right. So sketch 2. We're going to edit sketch. I'm going to remove the parallel. So I'm going to mouse over it, right click, hit delete. So they're no longer parallel. I am going to tell them that I want them to be perpendicular. So regardless of where they are, where they meet will be a 90-degree angle. And we're talking about the theoretical length of the line, not where it's actually touching. So if I finish this and I rotate this, they will always be perpendicular. It will always have a 90-degree angle wherever they meet. Okay? Still in length. Okay, so back to edit sketch. We are going to now, we talked about fix and unfix, so that locked that point in place. I click on that, notice it's not green anymore, so it's not fixed. So now if I go back to finish sketch, I should be able to move this point around. Okay. Next on the list is midpoint. So we are going to make this point be at the midpoint of this line. And so now no matter what we do, there will be an equal distance from this point out to here and out to here. So if I change the length, move it around, it's always at the midpoint. Now, that's very useful if you want to center stuff. Midpoint can also, and I'm going to right click and delete that midpoint. Midpoint can also be on two lines. So I'm going to hit midpoint and we're going to click that line and we're going to click this line. And now both lines are at the midpoint of each other. So I can move this around and that will always be an even plus sign. That the middle of this and the middle of this will always be together. All right click. I'm going to edit sketch. Now we're going to look at concentric. So concentric requires circles. So we're going to make a couple circles first. This one's pretty straightforward, although note that you can do this with line sections as well. So you can make, for concentric, you can make this circle concentric with this circle, and now they share a midpoint. You can also make this circle concentric to that line there, and notice that that arc fits inside the midpoint of this arc is the same as the midpoint of these circles. So that is concentric. Let's clean this up just a little bit. Finish this. Make a new sketch. We will place it on the X and Z axis. I'm going to take the visibility off sketch 2, so now we can look at the next constraint, which is collinear. So quite simply, collinear, we're sharing lines. So if we have a line here, and we have a line here, and we make them collinear, that one and that one, they now are on the same line. You can do this also with rectangles. So I can say I want this line collinear with this line. And now you'll notice that these are all on the same line. If I finish this sketch, mouse wheel to back up, click middle mouse to pan, I should be able to move this rectangle basically anywhere other than off of that line. So those lines are all collinear now. All right. Back to edit sketch, and we'll take a look at the constraints. Symmetry. So if we have L for line, we have a line over here, and a line over here, we can make this line and this line symmetrical around a center line. And so now these should be symmetrical. Note that it doesn't necessarily behave like you would expect it to for length. It gives your angle and it gives your distance, but not your length. If you want that to be, then you have to use the equal constraint. All right, moving on. We now have curvature. Okay, the next thing we're going to do is the curvature. So we are going to make a couple lines, L for line, put one here, put one here, And now we are going to put a spline between them. Spline was the curvy line, remember? So we're going to select this endpoint and this endpoint. And then we're going to hit OK. And now we should have a curvy line between them. That doesn't look like a curvy line. All right, notice my cursor's still on the spline tool. I'm going to hit Escape. And that is going to free me up to use these handles here. You could manually adjust these curves, but if you wanted a mathematical fit, I believe they call it G2 curvature. It'll tell us in the list. I'm going to deselect. Under curvature, G2 continuity. I really don't know what that means, but it's a standard for how you get curves to meet each other. I can get this to make a smooth transition from one to the next. This one's still lumpy. It still has a handle here. If I want it smooth to this one as well, I'll select this one and this one. And now we have a smooth transition across all of it. All right, and that is curvature.